Hi, good day, and welcome to my first video on kinematics. Now, I just want to explain that what I'm about to explain in these series of videos is for the CXC additional mathematics syllabus. And the main reason I decided to do this topic, it's because there are a lot of business students who also do additional mathematics and they don't do physics. So they usually have a hard time understanding the kinematics part of the additional mathematics syllabus. All right, so let's get started right away. I'm going to try to do this as slowly as I can. The first thing I want you to do is take down these four formulas. 1, 2, 3, 4. And for some of the letters, I specified what each letter stands for. Don't worry, I'm going to explain things like final velocity, displacement, time. I'm going to explain it in detail. Also, don't take this down. You're taking this down also. There are two types of graphs you're going to bounce up when you're doing this topic. One is called a displacement time graph, and these are some of the things that are relevant to these types of graphs. And another type of graph you are going to meet is something called a velocity time graph. And these things apply to the velocity time graph. So pause the video, take this and this down in detail, and then we are going to discuss them in detail. All right, so I'm going to assume that you took it down, and let's get started. The first thing that I really would like to clear up is that there's a big difference between speed and velocity. But I'm going to keep it really simple, especially since there may be a lot of business students who don't do physics trying to understand this topic. Let's try to understand the difference between speed and velocity. First of all, speed and velocity most of the times will be measured in something called meters per second. Another way of writing meters per second is meters s minus 1. This and this is the same. Right. Now here I have a car, and the car is going that direction at 50 meters per second. So what is the speed of the car? Well, the speed of the car is just 50 meters per second. And if I were to ask you the velocity, I would say that the velocity is 50 meters per second. So at first glance, it seems that speed and velocity is the same exact thing. However, there's a slight difference. Let's say that the car goes the other direction now. So the car turns around and goes this way at the same speed, 50 meters per second. Notice it's going the other way. If I ask you what is the speed would still be 50 meters per second. However, the velocity would be negative 50 meters per second. In other words, speed doesn't care which direction you go. The speed is always positive. Velocity cares about direction. So usually in a question, you have to denote or choose one side to be positive. So since I started off this way, I chose this direction to be positive for velocity. But if it reverses direction, it will be negative. Okay? Now I'm just going to let you know, in the additional mathematics questions, I've seen a lot in the past papers and whatnot. It's not going to make a big difference if you know the difference between speed and velocity. I am just showing you the difference just in case we get a question or we come across a question where it's really important. So sometimes, and this happens in a lot of textbooks also, sometimes you will see a graph called velocity time graph, and sometimes they call it a speed time graph, almost like it doesn't matter whether we call it speed or velocity. So for the time being, sometimes even I might make a mistake and say speed time graphs, and sometimes I might make the mistake and call it a velocity time graph. Just assume it's the same thing for for the time being, because it really won't affect our answer in most cases, right? All right, but I'm still pointing out the slight difference between the two just in case. All right, so let's do another one. Oh, there are a couple ways to measure speed and velocity. Most of the times your examiner will use meters per second. But if you're from the Caribbean, most of the times when you're driving a car, the speed is usually measured in kilometers per hour. So just like measurements, you can measure things in meters, feet, yards. You can measure speeds in different things. So let's say you have kilometers per hour and you are required to change it to meters per second. There must be a formula to convert kilometers per hour to meters per second. So I'm going to give you the formula. To convert kilometers per hour to meters per second, you have to multiply by 1,000 and then divide by 3,600. And if you have meters per second and you want to convert it to kilometers per hour, you just do the opposite. You multiply the value by 3,600, then divide by 1,000. Okay? Most likely you'll be doing it this way. Most of the questions that I have seen work in meters per second. So if they give you it in kilometers per hour, for example, if they told you something is driving at a speed of 30 kilometers per hour and we need meters per second, all you have to do is multiply this value by 1,000, then divide it by 3,600, and that will give us, let me do it quickly, 30 multiplied by 1,000 divided by 3,600, and we'll get 8.33 meters per second. All right, so most likely, and I'm going to remind you about it. I'm going to really nag you about it throughout the exercise. All right. So I'm finished with speed and velocity for the time being. So let's get that out of the way. All right. The next one I want to do is something called acceleration and deceleration. First of all, acceleration is measured in meters per second squared, or ms minus 2. And acceleration is something that makes something go faster. For example, when you're in a car and you press the accelerator, doesn't it cause the speed of the car to change? It will go from slow to fast. So an acceleration will make something go faster. A deceleration, well, acceleration are usually positive numbers. Like a car might have an acceleration of positive 5 meters per second squared. A deceleration is the opposite of an acceleration. A deceleration has a negative value, right? Well, a deceleration is just a negative acceleration. So that means, let's say I tell you, and this is really important, like let's go back to these formulas. You notice these formulas have an A. The A stands for acceleration. The D does not stand for deceleration. The D stands for displacement, right? So anywhere you see a D, it stands for displacement. So there is no letter for deceleration. So if somebody tells you that a car has a deceleration of 7 meters per second squared, you notice I put a positive, right? Because the deceleration is positive. But a deceleration really means a negative acceleration. So if I had to use this formula or this formula or this formula, and they told me the deceleration was 7, I would have to replace the A with negative 7. Okay? Really important to remember. All right. So that's it for the time. And a deceleration would just simply make something slow down, or make it go slower. All right. The next one, a distance and displacement. What's the difference between the two? All right. I'm going to use this diagram to explain the difference between distance and displacement. Here we have Jack. Jack wants an apple. So Jack plans to walk to the apple tree, pick an apple, and then walk back to this rock and sit and eat his apple. So he's going to walk like this. He's going to walk to the tree first and then come all the way back and sit here. If he ended up here, what distance did he walk? Well, from here to here is 20. So he walked 20, then he walked 8. So his distance is 28 meters. But what is his displacement? Displacement is just the amount of meters from the original position. So Jack started here. I don't care what he did. I'm going to pretend I just closed my eyes, and when I opened my eyes, I saw him sitting here. I didn't know whether he went by the tree or fought a dragon or whatever. All I know is he was here and he ended up here. This distance in meters would simply be 20 minus, well, if here's 20 and here's 8, that means here would be 12. His displacement would be 12. Displacement is just the amount of meters between the starting position and his ending position. Displacement is not concerned about all the tralala that happen in between. It only cares about beginning and ending positions. Distance is everything. He walked 20, then turned back and went 8. So his total distance walking was 28 meters. All right, guys. So I really hope this cleared up some of the basic stuff. In my next video, right, in the next part of this video, I'm going to show you how to use all of these formulas here to the best of my ability. All right. So see you in a few seconds. All right. So welcome to part 2, and today I'm going to show you how to use these, well, the first 3 formulas, 1, 2, and 3. I won't be using this formula until I do some harder questions. All right, so let's students have usually have a problem figuring out which of these 3 formulas to use, whether it's the black one, the red one, or the green one. So let's say we have a turtle. The turtle, when we now saw the turtle, it was already moving at 20 meters per second. Then it started to accelerate. Now here's the thing. I do not know the value of the acceleration. All I know is that the turtle accelerated for 5 seconds, and after that 5 seconds, because of the acceleration, it was now moving faster. It started off with 20 meters per second and it ended up going at a velocity of 50 meters per second. So first of all, we are trying to find A, the acceleration. So we have to choose a formula with an A in it. Okay, the black one has an A, the red one has an A, the green one has an A. That's really not helpful. Okay, let's try another way of figuring out which one to pick. All right, so there's a starting velocity and there's an ending velocity. That's good. The symbol for the starting velocity, initial velocity, that's the starting velocity, you always represent it with a U. So that means the initial velocity represented by the letter U, it has to be U, is 20 meters per second. And then the final velocity, you represent it with a V. That's the final velocity. That's the velocity it ended up with. All right. Next thing we have, so we need to choose one with an A, and we need to choose one with U and V, because U and V, well, we have values for them, so they can be really helpful. Which one of these formulas has U and V? The green one only has U. Yeah. The red one has V and U, so he's a potential candidate. He has V, U, and A. And the black one has V, U, and A. So it's between the red and the black. The green one is out. And they gave us time. The whole procedure took 5 seconds. The red one doesn't have time. but the black one has time. So my choice would be the black one. So let's write down the formula. V is equal to U plus A multiplied by T. And it's really a substitution game from this point. We're just going to replace the values. The final velocity was 50. The initial or starting velocity was 20. The acceleration is what we want to find. And T is 5. Okay, let's simplify this. 5 by A is just simply 5A. And to solve for A is really simple. You're going to throw across positive 20 to get minus 20. And that is going to be equal to 5A. 50 minus 20 is 30. And then you have to throw across the multiply to get the divide. I'm going to assume that you could transpose a little bit, right? 30 divided by 5 is 6. So that means my acceleration is 6 meters per second squared. Because acceleration is, you have to put it squared. It's not just, if you put meters per second, that's a measurement of speed and velocity. This is acceleration. You need to put a square there. All right? So that was the answer for the first one. It's pretty simple. Actually, all of them are going to be pretty simple, believe it or not. Even for somebody who's not doing physics, right? So, let's make sure if yeah, everything is correct there. Let's try another example. All right. You're probably realizing now I stole all of my my child's toys for these examples. All right. Let's try a next one. So let's say they had some people, they were on a boat, and the boat capsized. And you know how they just throw those little I call them, well, they call lifesavers, I believe, right? So one of the lifesavers got thrown into the ocean, right? And when it was thrown into the ocean, it was not moving. So it was at rest, okay? Anytime the examiner used that word, that something is at rest, the first thing that should come to your head is that it is not moving. So that means its initial velocity is 0. So sometimes they don't come out and say, hey, the starting velocity is 0. They use the word rest instead. So this is just floating in the ocean, not moving, it's just staying in one place. Then a wave hits it. So the wave hits it, and then it causes it to accelerate, sorry. And let's say the acceleration is 12 meters per second squared. So in this one, we actually know the acceleration. And because of the acceleration, it made the lifebuoy speed up. So let's say the wave hits it, and it speeds up to a velocity of 82 meters per second. Obviously, if the wave hits it and makes it move, it must move a certain distance. So we are going to try to find the distance. How far will this move, provided that it starts from rest? A wave makes it accelerate to a velocity of 82 meters per second. What would be the distance? Well, let's put in some values here. It starts at rest, so the initial velocity, wherever you see a U, the initial velocity is really 0. That's what they're really trying to say. And because of the acceleration caused by the wave, it sped up to, I'm not too sure if that's a word, it sped up to a velocity of 82 meters per second. So that's the ending velocity. And we are trying to find the distance. All right. So first things first, if we are trying to find the distance, we need to choose a formula with a D in it. The green one has a D, so he's a potential candidate. Red one has a D, potential candidate. The black one, no D. He is not a potential candidate. So it's between the red and the green. All right. Both of them have a U and a V. No, actually, the red one has a U and a V. And it also has a space for A. So I think the red one would be the better choice. The green one has an A, a value for A, but he requires a time for this equation to work. We don't have a T value. So the red one is the one that we need to use. So, yeah, that noise in the background is rain. I really hope, I'm going to talk a little bit louder, just in case. I'm not shouting at you guys, I'm just trying to outdo the noise of the rain here. So we're choosing the red one. V squared is equal to U squared plus 2 by A by D. Right? And D, you notice I use the word distance, right? But it's this formula, the D really means displacement. But you're going to find people use the word interchangeably, distance, displacement. Don't let it bug you, right? Let's plug in what we have so far. The velocity is, the final velocity, which is V, is 82, and we need to square it. The initial velocity or starting velocity, remember it started at rest. So it's 0 squared plus 2 multiplied by the acceleration caused by the wave was 12, and we are trying to find the displacement or distance. So let's do this. But 0 squared is just 0. I'm not even going to bother with that, right? 82 squared is 6724. And I'm not bothering with the 0 here. 2 by 12 is 24. Throw across the multiply to get a divide, and that will give us a displacement value of, let's put it here, the 82 squared divided by the 24. I got 280.17 meters. Pretty easy, right? Great. Let's try another one. Alright. Let's see, what's the next one? Alright. The next one we are trying to find the displacement also. Alright. Here we have a fruit. We're going to pretend that someone threw this fruit at someone. So when it left the person's hands, it was already moving at 3 meters per second. So it was already moving at, that's when it left the person's hand, right? And due to some acceleration, right, and the value of the acceleration was given, it was 8 meters per second squared. And the time this was thrown for, or the time this was airborne, the time was 4 minutes. Okay? Right. I want to know how far within that 4 minutes this fruit would move. Alright? So let's see what we've been given here. The starting velocity of the thrown item is 3. So that means U is 3. Right? So anywhere we see a U, we can replace it with 3. We need to choose a formula with a D, because that's the aim of the question, to find the distance this fruit makes it. So that means the black one is out. Only the red one and the green one has a D in it. Both of them also have an acceleration, so the red and the green is still in. But you notice they gave us a time. The red one doesn't have a time in it. And of course, the red one requires the final velocity. We do not have the final velocity. We only have the starting velocity. So I think the green one is the best choice out of all of them. So, and there's a slight trick in this question. I'm going to write the green formula. D is equal to UT plus a half multiplied by A multiplied by T squared. Great. You notice they gave you the time in minutes, but the speed is in meters per second. The acceleration is in meters per second squared. For this formula to work, the time needs to be in seconds. So we need to take the 4 and multiply it by 60, because there are 60 seconds at each minute. So that will give us 240 seconds. Now we can replace everyone inside here. The distance, we do not know it. That's the aim of the question. The initial velocity is 3. The time is 240 seconds plus a half. The acceleration was given to us. The acceleration was 8. And the time is 240, and we have to square this. So all we need to do is work this out on our calculator, and we'll get our final answer. So 3 multiplied by 240 plus a half is the same thing as 0.5. 0.5 multiplied by 8 multiplied by 240 squared. I'm just going to close the brackets there. And this is how much I got. Alright, I got 231,120 meters. Well, it's quite that's quite a big distance there. Alright, so I'm just going to double check my answer. Alright, that's all. 0.5 multiplied by 8 multiplied by 240 squared plus 3 multiplied 2, 3. Yep, I'm correct. Everything is correct. So don't worry, guys. I know I only did one question for him, one question for him, one question for him. When we actually start like past paper type questions, I'm going to introduce back these formulas, right? And you're actually going to see me work out the past paper type questions, 2 different methods. And you're going to realize, wait, no, there's 2 methods to work this out, and anyone is giving me the same answer. And I promise you, I will show you how to find the average speed when I've reached a question asking for it. Okay, guys? So the next part of this video, I'm actually going to introduce you to these graphs. Let me show you how to actually interpret the displacement time graphs and the velocity time graphs, also called speed time graphs or sometimes distance time graphs. See you in a few seconds. All right, so now I'm going to explain to you how to interpret a displacement time graph. That's the pink one here. Right? In the displacement time graphs, the y-axis will be displacement, and it's usually measured in meters. So this is showing you how much meters the object is moving. And the x-axis, will most of the times be time, while it will be measured in seconds. Now, in a displacement time graph, the gradient will be equal to the velocity. If you were to find the area underneath this red graph, it tells you nothing of value. All right, so this is only going to take like a few minutes to explain, because this one is super easy. If the examiner asks you what was the velocity between point O, I'm calling the origin O, between O and A. So what's the velocity between O and A? To find the velocity, you just have to find the gradient of that portion of the line. So the origin is 0, 0, and A, well, these dashed lines are guidelines, so the x value is 4 and the y value is 20, 4 and 20. So to find the velocity of this portion of the graph, I just have to remember my gradient formula, y2 minus y1 divided by x2 minus x1. I'm going to call the first point x1, y1, and the next point just what? X2 and y2. It doesn't matter if you call this one x1 and y1 and obviously the other one x2 and y2. So let's throw it into the formula. y2 minus y1. So y2 is 0 minus y1, which is 20, x2, which is 0 minus x1, which is 4. 0 minus 20 is minus 20, 0 minus 4 is minus 4. When you divide 2 negatives, you get a positive. So the gradient is of this portion of the line is 5, but the gradient tells us velocity, and velocity is measured in meters per second. So that means the velocity of this portion of the line is 5 meters per second. Simple. So now, let's say he asks you to find the velocity between A and B. Well, all you need to do is find the gradient of that portion of the line. So, the point A, the line starts at A and finishes at B. So A is 420 and B is 620. Right? wrote that really bad. 6. So I'll make these brackets a little bigger. 6, 20. Call the first point x1 and y1. Call the other point x2 and y2. And you just throw it back into the formula. Nothing is wrong with that. So y2 is 20 minus y1, which is 20 again. x2 is 6 minus, and x1 is 4. 20 minus 20 is 0. 6 minus 4 is 2. 0 divided by anything is 0. So the velocity between A and B, its velocity is 0 meters per second. If something has a velocity of 0, that means it is not moving. It is at a standstill. Okay? Right. Let's try the last one here. Let's find the velocity between B and C. So I don't need point A because this line starts at B and ends at C. So C is 8, 0. 8 on the X, 0 on the Y. Well, this one is already X2 and Y2. So the other point just becomes X1 and Y1. Like I said, I keep telling students this. When you have 2 points on the line, it doesn't matter which one you call X1 and Y1. The other one just becomes X2 and Y2. So let's see what happens between B and C. Y2 is 20 minus Y1, which is 0. X2 is 6 minus X1, which is 8. 20 minus 0 is 20. 6 minus 8 is minus 2. When you divide a positive by a negative, we get minus 10 meters per second. So our velocity between B and C is minus 10 meters per second. What does a negative velocity means? Remember, at the beginning of the video, I told you speed doesn't care what direction you are going. But velocity cares about direction. So this positive 5 means that whatever the object was moving this way. But between B and C, the negative sign indicates it reversed its direction. That is all the negative sign means in this case, right? So I'm not going to go any further with displacement time graphs. It's pretty simple. It's pretty simple, right? So the next one I'm going to do is velocity time graphs. That's the more popular one in the CXC additional mathematics examinations, right? So see you in a few seconds. All right. So let's go through velocity time graphs now. Now, in a velocity time graph, the gradient tells you the acceleration. Be careful, don't mix it up with distance time graphs where the gradient is velocity. And in velocity time graphs, the area actually tells you something. The area underneath the graph tells you the displacement. All right, so let's get started over here. Here I have a graph, and well, let's get all the points that we need. Between O and A, point A is 20, 10, so 20 seconds and 10 meters per second on the Y. Point B is 60, 10, and C is 100, 0. All right, so here's what we're going to do. We are going to find the acceleration for each portion. Let's assume that the examiner asks us for the acceleration between 0 and A. To find the acceleration, he's really asking us to find the gradient. So all we have to do is find the gradient between 0 and A. So let's do this quickly. Right? Well, okay, how are we going to do it? Well, this point is obviously the origin. So here it's 0, 0. Right? Right. The first point for us is always, just to keep it simple, will be x1 and y1. And the next point will obviously be x2 and y2. So we choose a point, 2 points on this line, the beginning and the end. y2, 10 minus y1, 0. x2, 20 minus x1, 0. So it's 10 divided by 20, which is 0.5 meters per second squared. So that means the acceleration of this portion is 0.5 meters per second squared, right? So now let's find the acceleration between A and B, right? So all we have to do is find the gradient of that line. So let's restart the whole process again. I know this is kind of repetitive, so if you're really comfortable with finding the gradient, you can just skip forward by pressing L if you're on if you have a keyboard in front of you. A is at the beginning of the portion AB, so we're going to call them x1 and y1, and B will be x2 and y2. Right? So throw it in the formula. Y2 minus y1. 10 minus 10. X2 minus x1. 60 minus 20. You're going to get 0 divided by 40, which is 0 meters per second squared. So the acceleration between A and B is 0 meters per second squared. Great. Let's find the acceleration between B and C. So B is at the beginning of the portion of the line that we're talking about. So we're just going to call it x1, y and y1, x2 and y2. Let's throw it into the formula here. Y2 minus y1. 0 minus 10. x2 minus x1. 100 minus 60. We're going to get minus 10 divided by 40, which is negative 0.25 meters per second squared. Remember, acceleration is measured in meters per second squared. So I'm going to write it here. The acceleration here is negative 0.25 meters per second squared. Whenever you see a negative acceleration, that means it's a deceleration. It's causing the object to actually slow down. Okay, so that's how you interpret a negative acceleration. All right, so that was pretty simple. Let's see if we can calculate the distance traveled between each portion. Between O and A, let's calculate the distance traveled. And then between A and B, we will calculate the distance traveled. And between B and C, we will calculate the distance traveled. And after we do that, if we add up all the distances, we will get the total distance traveled between O and the endpoint C. But anyway, the area underneath the portion of the graph is just the displacement. So I'm going to use a different color for these calculations. So this portion here, A, let's calculate the distance between O and A. This is really a triangle. A right angle triangle, base by height divided by 2. So base by height divided by 2. The base is 20. The height is 10. Right? From here to here is 10. You see it on the y-axis. And we have to divide it by 2. So this is 2 by 10, which is 200, divided by 2 is 100. Between here and here will be 100. Sorry for the small writing. 100 meters. Okay? So between here, the distance traveled between O and A is 100 meters. And of course, we did that by finding the area underneath the graph. But there's a second way of getting the same answer. Right? Keep in mind, but you see the answer there is 100. Suppose we didn't want to use that. Say we wanted to use one of these formulas to calculate the distance. Well, if we want to calculate the distance between O and A, we can only use values between O and A. Between O and A, remember, let's move this aside here. The starting velocity was 0 and the ending velocity was 10. So that means the initial velocity was 0 meters per second. The final velocity, which is at point A, was 10 meters per second. The acceleration from O to A, remember we found it by finding the gradient. The acceleration was 0.5 meters per second squared. And how long did that whole procedure take? It only took 20 seconds because between the beginning point of O and the ending point of A, only 20 seconds went on the x-axis. So the time was 20 seconds. So which of these formulas would be the best one to choose to calculate distance? I would choose this one because actually we could choose this one or this one. And let's see if either one will give us the correct answer. If we chose the red one, it would be, we'll have more space. Well, let me write it here first. V squared is equal to U squared plus 2AD. The final velocity was 10, so we have 10 squared. The initial velocity is 0. That was the starting velocity, so that's 0 squared. Plus 2, the acceleration is 0.5. Look at here. And this is his displacement. Let's see if we will get the same answer. 10 squared is 100. 0 squared is 0. 2 by 0.5 is 1. There's no need to put this. Throw across, but the 1 is a multiply. Throw it across, you get a divide. You will get a distance of 100 divided by 1 is 100. So the displacement was 100 meters. All right. So I proved it with the red formula. We can also do this with the green formula because we have enough information to use the green formula. So the green formula say displacement is ut plus a half at squared. Let's see if we'll get the same answer. We're trying to find the distance. The initial velocity is 0. The time is, well, 20 seconds. Plus a half, the A is 0.5. And the time is 20 squared. 0 by 20 is just 0. Let's type in this. A half multiplied by 0.5 multiplied by 20 squared. We get back the 100. So we had 3 ways to actually figure out the distance from O to A. Which one was easier? Wasn't it easier just to find the area underneath the velocity time graph? To me, that's always the easiest method, right? When you're trying to find distance or displacement on a velocity time graph. All right, I'm going to bring back him just now. All right. Let's find the displacement between A and B. All right, give me a few seconds here. All right, let's use a different color. If you want to find this distance here between A and B, put it in pink here. All right. So all we have to do is find the area underneath this graph, because the area underneath that portion of the graph, which is only the pink portion, will give us the displacement. That looks like a rectangle. How do you find the area of a rectangle? Length by breadth. Now I'm going to show you a common mistake made in these types of questions. I'm going to consider this to be the length and this to be the breadth, right? It doesn't matter if you mix up the length and the breadth, right? You're just going to multiply them anyway. My length is 60 because you're seeing the 60 here. And the breadth, well, is 10, right? From here to here is 10 on the y-axis. This is 100% wrong. Because even though I'm seeing 60, aren't we trying to find the distance from here to here, not the distance from A to B? So if here is 60 seconds and here is 20 seconds, then the total amount of seconds is really 60 minus the 20. The length is really 40, which is 400 meters. So the distance of this point is 400. Between A and B is 400 meters. Right? So be careful. If you need the length or distance from here to here, you have to minus the two values from beginning to end. All right? Could we still achieve the same answer using one of these formulas? I'm not going to use both again. I think I proved my point that there's more than one ways to get it out. let's just use the green one. Distance is ut plus a half at squared. Remember, we are trying to find the distance between A and B, traveled between A and B. So, at A, right, the starting velocity, remember the y-axis is the starting velocity, right? The y-axis is velocity. So the starting velocity at the beginning of the line was 10. So the initial velocity was 10. How much time went between A and B? 40 seconds, because here's 20 seconds, and then we went to 60 seconds. That's a total of 40 seconds. Plus a half, the acceleration, like I told you all, between A and B, where we actually calculated it, was 0. It's written right here. And the time is 40 seconds. That's the time between A and B. Anything multiplied by 0 is going to be 0. So this part is going to be void. Well, it's going to be 0. And 10 by 40 is 400. So my displacement was 400 meters. Great. Okay, let's find the displacement or distance moved between B and C. We just have to find the area underneath it. And this is a triangle. So it's base by height divided by 2. All right. The base is, we're going from 60 to 100. So that's 40, right? The height is 10. So 40 by 10 is 400 divided by 2 is 200 meters. Over here would be 200 meters. So how much is the, and of course, I'm not going to work out this one, but you could do a similar process. Use one of either the red formula or the green formula, and you would get back the 200. So how much is the total displacement, the total distance? The total distance is 100 plus 400 plus 200. That's 500 plus, that's 700 meters. So if they ask you for the average speed, you have to take the total distance, which is 700, and divide it by the total time taken. What's the total time for the entire journey? 100 seconds. That's how you calculate average speed. So the answer will be 7 meters per second. That's if they ask you to calculate the average speed. Alright guys, so I really hope this was helpful. In my next, the next part of this video, I'm going to try a past paper type question. Not an actual past paper question. Something very similar to a past paper type question, And it's going to be really challenging, so stick around guys.